So hopefully you have a good introductory understanding of what a hash table is. Now, you are going to hear that word hash in lots of different ways in Java, which can kind of get a little bit confusing. So I wanted to early on introduce some of the different ways that we find hashing in Java so that you kind of can keep this in the back of your mind as we're using that word hash in lots of different ways. So you will hear it, as I said, you'll hear that word used lots of different ways in Java, but also in computer science generally, you will hear that word hash used in different ways. So in computer science generally, and in other programming languages and just the area in general, the word hash table is that abstract data structure. It refers to that data structure that stores key value pairs. Other words you might hear that describe that same idea is a dictionary or a map or a table. Those are all different ways that you might hear a hash table described. So the just general term hash table is just referring to this abstract data structure. Just like the general term list just refers to an ordered collection of elements. Now within Java, right, we have the list interface and the ArrayList class and all sorts of specific things. But in terms of just data structures more generally, a list is one of those. And that's similar for hash table. A hash table is just a general data structure that exists in all languages, can be implemented in different languages and exists just in general in computer science. Now, here's a couple of the ways that you'll hear it in Java in particular. So there is a method that we'll talk about called hashcode. There is a class called hashset, and there's a class called hashmap. And there are others. These are not the only ways that you'll hear hash used within the Java standard library or within the Java language, but these are the three that we're going to focus on. So let's start out with the hashcode method. Well, this is a method that's inherited from object. So this is the class that all classes inherit from, right? This is the top of the inheritance chain in Java. And this is the class from which we inherit things like toString and equals, which you hopefully are already familiar with, right? So we know that every object has an equals method, and that's because it's inherited from capital O object. Every object has a toString method, and again, that's because it's inherited from capital O object. When you design your own classes, you should override those methods, right? You should override equals to define a logical equivalence between that makes sense for your objects. You should override toString to define a textual description of your objects. Well, there's another method that every object gets from capital O object, and that's hashcode. And what it does is, as you might imagine, it returns a hash code for a value for that object. So all objects have this method because they inherit it from object. And what this method is meant to do is that it's meant to define a hash function for that given object. So in the previous set of slides, we were using this hash function kind of written like this, that if I hash some object, it's going to give me some hash code. And we've been saying that hash code is the location or the index within a table of where that object is. So that same idea, but how it looks in Java is you would actually say my object, whatever your object is, and then you'd invoke the hashcode method, and that would return to you the hashcode value. Okay, so again, this hashcode method is meant to be that hash function. It's meant to define what a function is, what that hash function is for any given object. So if you have an object, you can invoke that hash code and you can get that hashcode method and you can get the hash code from it. Now this inherited version, the one that you get if you don't override it, it just returns a code based on the memory of the address of the object. So this is similar to how equals compares, if it's not overridden, it compares the memory address of two objects. Same thing with a hash code. It's just going to base its code on the memory address. If you write your own class, as I said, and you should override toString and override equals, well, I'm now going to tell you that whenever you override equals, you should also override hashcode. So from now on, from this point forward, you now know it. So now, you should always do that. Whenever you override equals, you should override hashcode. And that's because we have to follow what's called the contract that's defined by equals and hashcode. So because these are inherited methods, there are some things about them that we are supposed to follow. And you can look at that contract on the API page, so you can see it here for equals, and you can see it here for hashcode. Okay, so let's take a look at what those are. So the contract for the equals method, so this is kind of backtracking a little bit. Hopefully this is material you already know about writing equals methods, but when you override your equals method, these are all the things that should be true about the method that you write. Your equals method should be reflexive, meaning that if some object dot equals itself should return true. It should be symmetric, meaning that some object dot equals some other object. If you flip the order, if x equals y, then also y equals x. It should be transitive. If x equals y and y equals z, then x equals z. it should be consistent, which means that x equals y. That returns the same value upon multiple invocations, unless, of course, you've modified the object. But if you have not modified your object and you invoke an equals method in one place and the equals method in another place, you should always get the same value if you haven't changed the objects. Of course, if you've changed the objects, your equals method might return a different value. But if the objects haven't changed, the value returned from equals should be consistent. And the other thing in the equals contract is that if your object isn't null, then if you pass in null and compare your object to null, you should get a false. Okay. So these are all the things that your equals method should do. These are the characteristics it should have. That's the contract. Now the contract for hash code is related to equals. Your hash code method has to meet these criteria. So first of all, it has to be consistent. And that's just like we talked about with equals. What that means is if you invoke object.hashcode at multiple places and you haven't changed that object, then, sorry, this should not say equality, this should say hashcode, sorry, and you invoke it in multiple places and you haven't changed the object, then the hashcode method should return the same value. So it shouldn't be giving you different values unless you've changed the object. But the second part is that in addition to being consistent within the method, it also has to be consistent with equals. So what that means is if two objects are equal, so if I say that x equals y, then the hash code for x should be equal to the hash code for y. So these two methods should be consistent, and consistent in this way, meaning again, if your equals method says that two things are equal, meaning logically equivalent, x equals y, then the hash code for x should equal the hash code for y. Okay? Now, it's really important to note that the reverse of that last statement is not true. So it is true that two objects that are equal must have the same hash code. That's part of the contract. But again, the reverse, not necessarily true, and it's not required to be true. What that means that if you have two objects that are unequal, they could still have the same hash code. So if you have two objects and they have the same hash code, you don't know for sure if they are equal. If you have two that are equal, you know for sure they have the same hash code. But if you have two objects with the same hash code, they might not be the same object. They might not be equal. That is allowed. So that's not breaking any contract. Okay. When this happens, when you have two unequal objects with the same hash code, it's going to result in a collision, which we'll talk about in an upcoming video, and that is allowed. Okay. Now, producing distinct hash codes, meaning avoiding this idea of unequal elements having the same hash code, will result in improved performance. So you're going to get a better hash table the more you can avoid having unequal objects go to the same hash code. But it's not a requirement. It's not part of the hash code contract. It's just more about creating a better or more efficient hash code. Okay. So this is what the first place that we're talking about seeing hash in Java, and it's again through this hash code method. And the purpose of that hash code method is to define a hash function for whatever class that you're writing. How to link from that object into, map it to a particular integer value. The next place, before we get there, let's actually talk about how to write that hash code method. So I've told you that you should write it. Let's talk about how to actually write it. So there are two options for how you can do it. The first way to write a hash code method is to actually just combine all of the hash codes of your instance data variables and then combine them in with some prime number. So for example, let's say you have a movie class and the movie is described by a title, a director, and a year, representing the year it was released. So you might override your hash code like this. You might take the hash code for title, so this will invoke hash code from the string class, multiply it by the prime number 7. You might take the hash code for director, also which would be implemented in the string class, multiply it by 11, and then if year is an int, you can't invoke hash code on an int because you can't invoke any methods on any primitives, but you can invoke it on capital I integer, so that's actually, that shouldn't be there. You can say integer.value of year, which will give you a capital I integer object, and then invoke hash code on that. Multiply that by prime number 13. And then you add all these up. So you get this, plus this, plus this, and you put those all together, and that's your hash code. Okay. Now, for a long time, this was really the only way that people wrote hash codes. Okay. And in fact, a lot of IDEs, including Eclipse, we'll just automatically generate this code for you. So if you go to the source menu, there's an option there for generate hash code and equals. You can do that. Out will come a method that looks like this. You can modify it if you want to, or you can just use it as is. Now the textbook does get into some of the kind of nitty-gritty details about why we want a prime number here, and some of the web resources that I've shared kind of talk about that, the use of prime numbers a little bit too. That goes a little bit more into the weeds than we're going to get, but for those of you who are kind of interested to go down that route, there's a lot of information out there about kind of the relationship between prime numbers and creating good hash code functions. So you're welcome to kind of investigate that a little more on your own. But otherwise, you can just kind of take it at face value that this is a good way to write a hash code method. But as of Java 7, we have a second way to write a hash code method, and in my opinion, it's a lot easier. So what you can do is you can use this, I'm going to subjectively say that it's pretty awesome, shortcut that's it's a static method in the objects class. So this is objects with an S, not object. It's a different class from the one we just looked at. This is objects with an S, so totally different class. And in this objects class, there are a bunch of static helper methods. And one of those static helper methods is hash. So what you can do is you can just invoke that static method and pass in all your instance data variables. So we can just say objects, again, note the S, dot hash, and send in however many you've got. Title, director, year. If you had 5 more, you can send all those in too. So this is a super easy way to write a hash code method. Okay, and this is again new as of Java 7, which is actually a few releases ago, so it's not that new anymore, but it's still pretty great, and it's a lot easier in my opinion than the old method of writing the hash codes. So 2 different options that you can use there. Okay, so that's one way that you'll see hash in Java. The second way we're going to talk about is with a class called HashSet. So HashSet is a class in the Java Standard Library that implements the set interface. So this is the class for HashSet, and you can take a look at the API page and read a little bit more about it. You can also flip over to the interface for set. This is the interface that it implements, and you can read more about it there as well. We're not going to spend a lot of time talking about sets. That's a bit beyond the scope of what we're doing, but I want to talk a little bit about HashSet just so that you get another flavor for how hashing is used in Java. So what a hash set is again, it's a class that implements the set interface. And what the set interface is it's an abstract data structure. So it's a data structure, a collection of objects, and it's a collection that is unordered and does not allow duplicates. So it's a little bit similar to a bag, only with a bag we could have duplicates, and with the set you cannot. Okay, so a set is just an unordered collection, but no duplicates are allowed. Okay, so from the client view, for us writing a program, we decide to use a set. We can declare our object as type set, and we can initialize it as type hash set. So just like we say list, my list equals a new array list, we can say set, my set equals a new hash set. So from our client view, it's just a set. A hash set is just a set. It just allows us to add things and remove things from a group. It won't allow us to add a duplicate. And this is the view we take when using HashSet. So when we're creating a set, we just specify the values. We just specify the objects we want to put in the set. So we create a set and then we add things to it. So in that way, HashSet is a lot like a list, right? When you create a list, you just add things to it. When you create a set, you just add things to it. But a hash set, behind the scenes, it's figuring out that key. So again, we provide the value, that's the object going into the set, but behind the scenes, the HashSet class is figuring out that key using the hashcode method for that particular type of object. Okay, so this is why it's called a hash set, because behind the scenes, it's using that hashcode method. It's using hashing behind the scenes. Okay. HashSet is a very, very efficient class to use when you don't need elements to be ordered and you don't have any duplicates. So if this describes your data, if you don't care about ordering, you don't care about position, and you don't have any duplicates, HashSet is great. Might not work for every case. It really depends on the problem, but you should definitely consider it, at least consider it, if you have a data set that doesn't have any duplicates and doesn't need to be ordered. If you are going to use HashSet, be extra certain that you have properly overridden both equals and hashcode in whatever class it is that you're storing into this HashSet. Because if you haven't done that, it's not going to work correctly. Okay, so you have to make sure you've overridden those methods, follow those 2 contracts, and then you'll be good to go to use HashSet. So again, behind the scenes, hash set is implemented with a hash table, and that's why it's got hash in the name. So it really is just a set, but it's implemented with a hash table. So like the ArrayList class is just a list that's implemented behind the scenes with an array. It's called ArrayList. And linked list is just a list that's implemented behind the scenes with linked nodes. It's a linked list. In the same way, hash set is just a set, but it's implemented behind the scenes with a hash table. So you can kind of remember that's sort of the convention for how a lot of these classes are named. Okay, so how this works is that behind the scenes we have this hash table, and when you try to add an element to the table, to the hash set, what it does is it looks up the hash code, gets the hash code, goes to the table, sees if the element that you're looking for is there at that location, and if it is, it gives it back to you, and if it's not, it adds it. Was I talking about add there? Yeah, sorry. I'm talking about if you're trying to add is. Okay. So this is, again, very fast lookup. It's constant time instead of linear time, right? If you want to retrieve something, you give the key. In this case, you give the object, and hash set figures out the key by invoking hash code, and then it uses that key to go into the hash table to see if what you're looking for is there, and if what you're looking for is there, it gives it back to you, and if not, you are notified. I think it returns a null. Okay, so that's what makes it so efficient. Again, is that behind the scenes, it's implemented with a hash table. Okay, the add method also uses hashing, because when you try to add something to a set, it will use that hash code method to first check and see if that element is already there. And it's only going to add an element to the set if it's not already there. But here you can kind of think about how it's so important that hash code and equals are consistent with each other, because we're using hash code to find the location where our element is. But then once we find that element, we might need to compare it to what we're looking for to see if it's already in the table, right? So hash code and equals, they really do have to be consistent. You have to follow those contracts, okay? And again, make really sure of that if you're using hash set. But again, hash set is just a very efficient implementation when you don't care about order and you don't have any duplicates. And it's just a set. It's just a collection of objects, unordered objects, but behind the scenes, it's implemented with a hash table. So you don't provide the key, Java gets the key, and it gets the key from that hash code method. That is very different from the next class we're going to talk about, which is hash map. A hash map implements the map interface, which is another interface that you can look at, and you can also look at the hash map API page, read a little bit more about it. But essentially, a map is a data structure that stores key value pairs. So this is another word for a hash table. So a map, and in particular hash map, these are essentially Java's way of providing a hash table, right? So just like, ArrayList is one of Java's main ways of providing the list ADT. Hash map is one of Java's main way for providing the hash table ADT. And this is where it kind of gets a little confusing with the language, because I'm telling you the class is hash map, and I'm also telling you it is a hash table. So again, kind of try to keep these things separate. The class name is hash map, and this is an example of the abstract data structure hash table, right? Just like ArrayList is a class, and it's an example of the abstract data structure list. So same idea. So again, hash map is basically Java's version of a hash table, and it allows you, the user, to specify both the type of the object that'll be the key, as well as the type of the object that'll be the value. So this is really different from a hash set. With a hash set, we're just putting objects into the set, and then behind the scenes, Java is using that hash code to figure out how to store everything into a hash table. But we never see that. With a hash map, we're actually building the hash table. We say what the key is, and we say what the values are. So this most likely will not even use that hash code method. You can choose to use it, but more than likely, you're going to use some other key that you define. The point is, you get to decide. You get to decide what the key is, and you get to decide what the value is. So for an example, let's say you were storing movie data, perhaps you'd create a hash map where the type of the key is a string and the type of a value is a movie. And this, maybe you have these unique movie IDs, that's the key, and then the movie object is your value. Or let's say you had a hash map where the key is some employee ID, numeric employee ID, and the value is an employee object. So this is allowing you to create your own key value pairs, right? You define what the key is and you define what the value is. Now, how this works is that there's a put method, and when you send in the key and the value to the put method, the put method will replace and return the element if one is already there. So put goes into your hash table, your hash map, and it uses that key to find the location, and then it says, hey, is there already a value there? If so, it replaces it, returns you the old one. If not, it just adds it into the table. Okay. The get method, you can send in the key, and that returns either the element at that particular position or null. So again, you give the hash map class your key, it uses that to find the value, and then either gives it to you or gives you null. Okay. So in the use of these methods, you are not actually calculating how the key leads you to the location. So in those initial examples we were looking at, I was actually showing you, for example, take the last digit of the phone number. That's how you go from key to location. With a hash map, it's more abstracted from that because you're just using the Java class. So you specify the key, what the key is, you specify what the value is, but you don't actually have to worry about, well, how does that key get translated into a location? Just understand that that is what's happening. Behind the scenes, that key is getting put through a hash function and it's giving a location, and that location is where your value is. But you don't have to do that calculation. It's done for you by the hash map class. Okay. So as I've kind of just implied there, behind the scenes, hash map is implemented with a hash table. So to further confuse things, hash map is a hash table and hash map is implemented with a hash table. So hashing all over the place. Okay. One other very useful method with the hash class is a method called keySet. And what this does is it returns to you a set of all the key objects. So if you're given you want to know everything that's in your table, you can invoke the keySet method on your hash map, and that'll give you a set of keys. You could then iterate through those sets, and for each key, you can say, okay, give me the value for that key. Next one, give me the value for that key. So that's a way of accessing everything in your hash map if you need to. Similar to hash set, hash map is very efficient, so they're both very efficient, and also hash map is unordered, right? So if you don't need your elements to be ordered and you're looking for some efficient retrieval and you want to be able to define the type of the key and the type of the value, hash map is a great choice. The other thing to think about is that hash map doesn't automatically, by design, it doesn't allow you to store multiple values at the same key location. Okay, so there are ways to do this, and we're not going to go into those, but they're a little bit more complicated. You can't use it in a direct way. So if you need to store more than one element at a location, you might have to think about using hash map in a little bit of a different way. Okay. So those are things to think about in terms of when you're thinking about whether you want to use hash map. So what we're going to look at now is we're going to look at some coding examples of writing the hashcode method, of using a hash set with our own hashcode method, and then also using hash map by defining our own keys and values.